Welcome to Auto Tech Bytes. Today's topic of discussion is TCP/IP reference model. So we will look into how the TCP/IP reference model is used for Ethernet communication on the automotive bus. Okay, and as you can see, we have 5 layers in the TCP/IP model, starting from the layer 1, which is the physical layer, and then we have the layer 2, which is called the data link layer 3, which is called network layer or the internet layer, and the layer 4, which is called the transport layer, and the layer 5, which is called the application layer. Now we will see what each layer does. To talk about the layer 1, which is the physical layer, deals with the binary representation of data, which is zeros and ones. So it does not send any kind of information with respect to the hardware. At layer 2, we can see that there is layer 2 header which is appended along with the payload. So what is this layer 2 header? Layer 2 header is nothing but the MAC header. What MAC header means is the MAC refers to hardware and it includes the hardware address. Every PC on the network will mandatorily have a hardware address in order to communicate on the network at the physical and data link layer. If you run the command line on your Windows PC with command ipconfig, you will see the MAC address of the PC. If you turn off the PC and restart, or if you disconnect the internet and connect it back, you will see that the MAC address which was displayed will remain same and does not change. Now, to talk about the layer 2, where we have the layer 2 header and we are talking about the MAC header. This includes source MAC and destination MAC. So when a host A sends to host B, the destination MAC is nothing but your host B's hardware address. When host A is sending, it appends the source MAC, which is nothing but the hardware address of host A. So when there are two ECUs on the network, ECU 1 and 2, they communicate over the MAC addresses of the two hosts. When a particular ECU receives the packet, it checks whether the destination MAC matches with the received MAC. If yes, then it removes the header and sends the remaining data to upper layer. Similar to how we spoke about the MAC addresses here, we have something called IP address at network layer. This will also have destination and source IP addresses. So now when the IP header is received, the host 2 or the ECU 2 checks whether the destination IP matches with the IP address of the host or the ECU. If it matches, then it removes the header, sends the remaining data to upper layer. At layer 4, we talk about port addresses. The TCP UDP header will consist of source port number and destination port number. Now again, similar to how we saw about MAC address and IP address verification, the host will verify whether the destination port matches the port that is configured in the host or the ECU. Then it removes the header and sends the remaining data to upper layer. Now, this is the application layer. At application layer, we may have one of the protocols as DOIP, which is nothing but diagnostics over IP communication. That is nothing but internet protocol. So we are trying to send the diagnostic request over internet protocol. Because we are using internet, we are using IP addresses for communication. So this will have DOIP header, which includes protocol version and the header information, which is validated as per the configuration of the ECU, and it removes the header and sends it to upper layer. So at application layer, the user who is accessing the data could be a diagnostic module. So user receives the data independent of the underlying protocols. Even though we are sending it over the Ethernet, only the 5 layers of your Ethernet protocol will be aware of what is the header. But the upper layer, which is above application layer, is independent of the protocol which is underlying the uh, application layer. Now that we saw all the headers and the data information, we also have something called CRC. So CRC are of two types. So we talk about the hardware implementation of CRC and software implementation of CRC. The Ethernet hardware rejects the packet if the CRC does not match. If the CRC is valid, then it forwards the packet to upper layer. Now, I can choose to accept the packet either based on hardware implementation, or I can write my own algorithm to verify the CRC of the packet. If I support the software implementation, then there is a feature called offload checksum feature, which is turned on in order to ensure hardware does not drop the packet. Instead, it will stop checking for CRC and it will forward the packet, and the upper layer where the software implementation of the algorithm for CRC verification is done will verify if the CRC of the packet matches the CRC trailer. This is called the trailer. So if they are equal, then it validates and accepts the packet. If not, then the software takes care of rejecting the packet. So this is what we wanted to look into today as part of the TCP/IP reference model.